Hello guys, this is Manoj Kumar Jillela. Today the topic is first come first serve scheduling algorithm. Before going to this, let us see process scheduling. This process scheduling is done in two ways, preemptive and non-preemptive. First one, preemptive. For example, let us consider a process which is in new and it enters into the ready state. At first, it is in the ready state, and at certain time, it enters into the it goes for execution to the running state. And after some time, it forcefully terminates back to the ready state. It is called as non-preemptive scheduling algorithm. Here, the process starts from new and admitted into the ready state, and it at a certain time it goes to the running state, that is for execution, and it is released voluntarily after completion of process. Then there is no interruption, that is coming back to the ready state. It directly goes back to the exit state. There is no interruption while the example for this non-preemptive algorithm is first come first serve scheduling algorithm. Let us see first come first serve. In this first come first serve scheduling algorithm, as the name suggests, the process which arrives first gets executed first. That is, it uses the queue data structure. The process are added at the backside. First come first serve is just like FIFO, first in first out, where the data element which is added to the queue first is the one who leaves the queue first. Let us learn some notations. Arrival time, AT, time when the process admitted into the ready state. That is, what is a ready state? Here, the process is admitted from new to the ready state. Then the process at which it is arrived to the ready state is called arrival time. Turnaround time. Completion time is CT and burst time is BT. Completion time minus arrival time is called turnaround time. Next, waiting time. Turnaround time minus burst. An example. Here there are 6 processes, that is A, B, C, D, E and F. Now at 0 millisecond there is no process entering into the ready queue. So 0, nothing. So the process entered into the ready queue is at 2 milliseconds. Then 0 to 2 is called ideal condition. You can mark it as next. At 2 milliseconds, the process entering into the ready queue are C and D. C, D. Here, the arrival time of both C and D are same. Then, this is called a tie break. This tie break can be resolved based on the PID, that is process ID. Next, at 2 milliseconds, only C and D are entered into the ready queue. Now C is processed first, as it is the first come first serve algorithm. C. The burst time of C is 2 milliseconds. 2 plus 2, 4. Next, at 4 milliseconds, the process entered into the ready queue are DVF. The D is already entered. D, B, F. So D is scheduled first. The burst time of D is 3 milliseconds. So 4 plus 3, 7. Next, at 7 milliseconds. At 7 milliseconds, the process entered into the ready queue are A. Already B and F are entered. B, F, A. Now, B is scheduled first. The burst time of B is 1 millisecond. 7 plus 1, 8. Next, at 8 milliseconds, the process entering the ready queue are only E. Already F and E are entered. F, A, E. So F is scheduled first. F. The burst time of F is 2 milliseconds. 8 plus 2, 10. Next, after 8 milliseconds, there is no process entering into the ready queue. So, A is scheduled. Burst time of A is 2 milliseconds. 10 plus 2, 12. At last, E is scheduled. The burst time of E is 1 millisecond. So 12 plus 1, 13. So the Gantt chart is ready. And now you should calculate the average turnaround time and average waiting time. The completion time are as follows. First, the completion time of A. The completion time of A is 12 milliseconds. Here we can see. Then next completion time of B is 8 milliseconds. Next completion time of C is 4 milliseconds. Next, here there is a condition in non-preemptive scheduling algorithm. That is, the response time is equal to the waiting time. Here we can see that in non-preemptive scheduling algorithm, response time equal to waiting time. So we can write same 4, 4, 0, 2, 4, 5. Now the average turnaround time into 5. The average turnaround time is 5 milliseconds. Next, average waiting time 3.16. Scheduling length. The scheduling length 2. 11. Next, throughput 11. Let us consider the final example. Here there are three processes P1, P2, P3, and at 0 millisecond the process entering into the ready queue are 3 process, that is P1, P2 and P3. That is 21.6. Here the average turnaround time is 35 and the average waiting time is 21.6. The waiting time, as the process P1 has a burst time of 30 milliseconds, the process P2 and P3 has to wait for long time. The process P2 and P3 has to wait for long time, as the burst time of P2 and P3 are small, that is 5 milliseconds. Here there is a disadvantage that the larger CPU cycles followed by the smaller CPU cycles gives us the convoy effect, which is the disadvantage of this first come first serve algorithm. Due to this larger burst time of P1, the P2 and P3 has to wait more long time, as the average waiting time and the turnaround time increases. This is known as the convoy effect. This is the main disadvantage of this first come first serve. The simplest form of CPU scheduling algorithm. Yes, it is simple. And implementation is easy. Why? We use queue data structure for implementation. It is easy to schedule. As we seen before, it is schedule which comes first. It is taken into scheduling which is coming first. So it is easy to schedule, and this is non-preemptive scheduling algorithm. Fair type of algorithm, that is, it is based on the arrival time. So these are advantages of first come first serve, and disadvantages are mainly convoy effect. The longer job, that is in a above example, the longer job is at first, so it should be scheduled first. Afterwards there are 3 shorter jobs. These 3 shorter jobs suffer due to this longer job. I hope you have understood well. Thank you.